All right, I wanted to help you out in case you're looking at these exponents thinking what is happening. All right, so if you notice on this sheet, 1 and 3, those are similar. 2 and 4 are similar. 5 and 7, 6 and 8, 9 and 11, and then 10 and 12. So I'm going to do one of each type to show you how this is working. So for number 1 here, I'm going to add that little exponent of 1 by the 3. It's invisible, but I'm going to write it in there so we don't forget about it. Okay, if it's a positive exponent, it stays where it is. It doesn't need to be moved. So the 3 stays, the end of the fifth stays, but the m to the negative third needs to move downstairs, and then the negative 3 becomes a positive. When you move it upstairs or downstairs, that's how we're making the next exponent positive. So 3 stays, end of the fifth stays, and then I'm done. All right, number 2, I'm going to add those little invisible 1 exponents again, so we don't forget about them, because this squared is basically being distributed to all 3 parts inside this parenthesis. So 1 times 2 is 3 to the second. Again, the exponent is 1 times 2, n to the second. 3 times 2 is m to the sixth. All right, then here we can simplify that. 3 squared is equal to 9. So I have 9n squared m to the sixth. All right, number 5. Again, add those invisible exponents to help you out. So this negative 3 is being distributed to both. So I have 6 to the negative third. 1 times negative 3 is negative 3. 4 times negative 3 is negative 12. If they're negative, they need to be moved. So both of these need to move downstairs. So I have over 6 to the third and then b to the 12th. They both go downstairs. Nothing's left on top, so that's just a 1. Now, you can always write 6 to the third as the number that it is. So on your calculator, do 6 caret 3. Okay, so it's 6 times 6 times 6. Okay, so it's not 18. You should get 216. So 1 over 216, b to the 12th. All right, number 6. We have to combine like terms. So the y's can be combined. I have y to the first over y to the negative second. So I have 1 minus negative 2. So that's becoming a 3. So on top here, that this 3 here stayed. Now I have y to the positive 3. So whenever you subtract, the term always goes on top. And then if you needed to move it, then you would do that. All right, and then this guy here is still on the bottom. You might be thinking, oh, I could have done that all one step. Okay, awesome. So I knew this needs to go up. So I have 3x to the fourth, y cubed, and then we're done. Usually we just like to write them in alphabetical order. So like A, B, C, D, X, Y, Z. All right, and then we have 2 more exponent problems. So here, let's simplify first and then multiply. Anything to the 0 power here is 1. So I'm just going to cross that out. Add my invisible exponent. So I have 2 to the negative second, b to the negative second. Since this is times 1, we don't really even need to write that. So both of these need to go down. So 1 over 2 squared, b squared, and then 2 squared is 4. So we'll write it like that. All right, last exponent 1. I need to multiply my big numbers. 2 times 4 is 8. Now I will worry about my a's. Since there's 2 bases, I add my exponent. So I have 3 plus 4. So I have a to the 7th, and there's no other b's, so it's just b to the negative 4th. Then see what you need to move. This guy needs to go downstairs. So I have 8, a to the 7th over b to the 4th. Okie doke. All right, down here, Sam bought a car that's depreciating at a rate of 18% per year. Write an exponential equation to model this. All right, so your exponential equation format is this. So my b, I have to figure that out. 18%, I need to move my decimal over 2. So I have 0.18. I either have 1 plus or 1 minus. This word right here is telling me it's decreasing. So that's subtraction. So I have 1 minus 0.8. So think $1 minus 18 cents. Okay, you should get 0.82. That's your B factor. And then my A, that's my initial value. Okay, so, we don't have initial value, do we? Let's make that up. Your initial value is $30,000. Okay, I forgot to add that in the problem, so I'm just, fixing the problem now. All right, so we have y equals 30,000, and then times my 0.82 to the x. That's my exponential equation. So is this the growth or decay? You want to look at your b value here. If it's less than 1, it's decay. If it's greater than 1, it's growth. So that is less than 1, so it's decay. All right, last one, the graph. What's the y-intercept? Y-intercept is right here. Write it as a point. So you should get 0, 2. Equation of the asymptote, that's this dotted line down here that the graph will never cross. Okay, so it's a Hoyer-Bucks line. Since it's a horizontal line, it's y equals -2. All right, domain, that was your free points. All the values to the left, all the values to the right. Then my range, if I do bottom to top here, this is not going below -2. So that's my starting value, -2, and it's going to go up forever. So it's going to go up to infinity. There's not a bracket here because it's a dotted line. This graph is never actually touching -2. That's why. All right, there we have it. Nice job.